Good day, everyone. I am Daniela Joyce Abertes, and today I will present a recent article from the Philippine Council for Health Research and Development entitled Students Gain Hands-on Experience in Neurosciences, Sparking Curiosity in Brain and Mental Health, published on October 24, 2025. This article highlights an educational program called NEUROLAKBAY, conducted at the UP-NIH Behavioral Neuroscience Laboratory, where Filipino students got the opportunity to experience the art of neuroscience up close. The currently discussed article firstly emphasizes a salient problem in our country, which is the limited public and academic exposure to neuroscience. Neuroscience is a multidisciplinary field that underpins our understanding of cognition, emotion, behavior, and psychiatric disorders. Yet, in many local settings, there is a gap in awareness and training, which constrains research capacity and clinical expertise. This gap is particularly concerning given the rising prevalence of mental health conditions, such as depression, anxiety, and substance use disorders that require both biomedical research and community interventions. NEUROLAKBAY attempts to address this gap by providing experiential learning where students are not only told about brain concepts but directly experience and observe brain anatomy and physiological signals. This experiential approach can correct misconceptions, reduce stigma, and provoke interest in careers that contribute to mental health research and care. In NEUROLAKBAY, students learn neuroscience through three main stations. First, the brain anatomy and microscopy activity showed how the brain physically changes when exposed to substances, demonstrated by comparing healthy and drug-exposed mouse brains. Second, biosignal monitoring introduced EMG, EEG, and ECG tools that measure electrical activity in muscles, the brain, and the heart. This helped students see how the nervous system communicates in real time. Lastly, the sensory processing experiments showed how the brain interprets information through perceptions and illusions. Together, these activities provided a clear and hands-on understanding of how the brain works. For the technological applications of NEUROLAKBAY, NEUROLAKBAY highlights how technology supports neuroscience education. Next, the use of physiological monitoring and diagnostics. The demonstrations using the EMG, EEG, and ECG showcase how technological tools can help monitor the brain activity. They are made to help students understand how these instruments are used in diagnostics, research, and patient monitoring. Lastly, the program encourages young people to pursue research, strengthening local scientific capacity in the Philippines. These interactive ways also serve as modern approach to science learning, making neuroscience more accessible. In terms of the societal impacts of NEUROLAKBAY occurrence, starting off the local impact, NEUROLAKBAY promotes mental health awareness among students and helps address the shortage of neuroscience professionals by inspiring interest in brain-related careers. Whereas the global impact, it contributes to broader efforts to improve mental health education and research. Programs presented like in this article being discussed support global scientific advancement by helping more communities understand brain function and behavior. Moreover, this news connects strongly to BS pharmacy due to the fact that many medications act directly on the brain. NEUROLAKBAY demonstrated how certain substances, including addictive drugs, can alter brain structure and function. This article also shows its relevance to pharmaceutical concepts for antidepressants, antipsychotics, and anti-anxiety medications being involved in neuroscience practices. Overall, it reinforces the pharmacist's role in promoting safe medication use and educating communities about substances that affect the brain. Thank you for watching!